Good afternoon, everyone. How are you all? Good afternoon. I hope you all are doing good. See, today we will start the topic significant figures from chapter units and measurement. So I request you all to please mute your mic unless and until you have any doubt. So what are significant figures? Firstly, we will discuss that, but I will take some example first, then I will explain that. So suppose you have meter scale, the scale you have in your geometry box or in your bags. So this is the calibration of that scale. So 0, 1. So how many divisions between 0 and 1 centimeter? How many divisions are there in your meter scale? 10 divisions. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my divisions are not equally spaced, but that divisions are usually equally spaced. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions are there. So this is 1 centimeter. So one division is of 1 centimeter upon 10, that is 0.1 centimeter, or we can say it 1 millimeter. Now, if you have anything, suppose any rod, any stick you want to measure, or any object you want to measure. So suppose I have a small object and I want to measure it, and this is another divisions after 1 centimeter. Suppose its length is this. Okay, so that is the object. Now this is 1 and first division, second division, third division. So what is the measurement? It is 1.2 centimeter or 1.3 centimeter, or in between 1.2 and 1.3. So as you can see, it is not 1.2 centimeter and it is also not 1.3 centimeter. It is between 1.2 and 1.3. So if suppose 4 or 5 students are taking readings, so one student can write 1.23 centimeter, or another student can write 1.24 centimeter, or suppose third student can also write 1.22 centimeter, and some another student can write 1.25 centimeter. But the actual value may not be from that four values, or we can say the actual value is 1.22 centimeter, but the others are writing it 1.22 centimeter, 24 centimeter, 25 centimeter. So why they are writing different readings? Because that last digit is uncertain. It is not certain because this meter scale can measure up to 0.1 centimeter accurately. It cannot measure beyond that. So ये 0.1 centimeter, only one decimal place, up to one decimal place, or we can say up to 0.1 centimeter is its least count. तो लीस्ट ये रीडिंग कहाँ तक ले सकता है? 0.1 सेंटीमीटर. तो यहाँ पे हम रीडिंग जो लिखी है 1.23 सेंटीमीटर, it is up to 0.001 centimeter. So it cannot measure. So ये जो हमने लास्ट डिजिट लिखा है वो हमने प्रिडिक्ट किया है. तो हमारी मेजरमेंट में जो डिजिट सर्टेन है प्लस वन डिजिट दैट इज अनसर्टेन, दैट आर नोन एज सिग्निफिकेंट फिगर्स इन एनी मेजरमेंट. सो किसी भी मेजरमेंट में जो हमारे पास सर्टेन डिजिट्स हैं जो हमें पता है कि वो हैं एक्चुअली, ठीक है, यहाँ पे हमारे पास जो रॉड की लेंथ है वो 1.2 सेंटीमीटर और 1.3 सेंटीमीटर के बीच में है। तो 1.2 is certain, but it is between 1.2 and 1.3, and this digit 3, 4, 2 or 5, that is not certain. So that is one digit that is uncertain. Please mute your mic. Okay, so that is the definition of significant figures. So reliable digits, the reliable digits, or we can say certain digits, plus the first uncertain digit are together called significant figures. So these three, all three digits are significant figures, out of which these are reliable, 1 and 2 is reliable, and that third digit is uncertain. So that are known as significant figures. Understood? Any doubt? Yes. Okay. Example, length measured as 2.308 have four significant figures. So that 2, 3 and 0 are certain, and that 8 is uncertain, and that is unreliable, we can say. And a large number of significant figures in any measurement represents the precision. So there are two terms, one is accuracy, another is precision. So what is accuracy and what is precision? So suppose there is a dartboard. I will explain. Or we can say that is the target for archery or for shooting. So that is, suppose that is the region for 10, and that is for 9, that is for 8, that is for 7, and so on. Okay. Suppose some arrows are projected towards it, and would change the color. In the first case, suppose first arrow hit here, second arrow here, third arrow here, and fourth arrow here. Now in that case, what is accuracy? Accuracy is the closeness of measured value to the actual value, or we can say true value. So how much close the measured value is to the true value, that is accuracy. So in this case, suppose, so what give you 10 marks? If you project your arrow, if your target will if your arrow will hit at this, in this region, in the region of 10, otherwise you will get 8 or 9 or 7. So in this case, accuracy is low. Okay, and what is precision? I will explain. In the second case, suppose in this case accuracy is low. In the second case, if suppose for second case, these are the points where arrow has been targeted. So यहाँ पे arrow लगाया जाके, तो अब ये 4 पॉइंट्स ये हैं. सेकेंड टाइम किसी दूसरे आर्चर ने यहाँ पे जो एम करे हैं वो यहाँ पे आके हिट करे हैं इन 4 पॉइंट्स पे. तो यहाँ पे आप देख सकते हो जिन पॉइंट्स पे हिट किया है एरो ने वो बहुत क्लोज है एक दूसरे से, पर वो यहाँ से 10 से बहुत दूर है, पर आपस में क्लोज है. तो इसका मतलब क्या है कि यहाँ पे प्रिसीजन ज्यादा है, हाई प्रिसीजन. और इस केस में क्या है, लो प्रिसीजन, ऑल्सो लो एक्यूरेसी. एक्यूरेसी हाई कब होगी? जब 10 के क्लोज, ये सारे शॉट्स जो होंगे 10 के क्लोज लगेंगे, तब हम कहेंगे हाई एक्यूरेसी. तो ये लो एक्यूरेसी है, ये भी लो एक्यूरेसी है, बट ये हाई प्रिसीजन है, क्योंकि सारी ही जो मेजरमेंट्स हैं वो आपस में कितने क्लोज है। एक्यूरेसी ये बताता है कि जो मेजर्ड वैल्यू है वो ट्रू वैल्यू के कितना क्लोज है। प्रिसीजन बताता है कि जो सारी मेजरमेंट्स आपने करी हैं वो एक दूसरे के कितनी क्लोज है। ओके, अगर वो सारी मेजरमेंट एक दूसरे के क्लोज आ रही हैं बट ट्रू वैल्यू के क्लोज नहीं है, इसका मतलब कि आपकी मेजरमेंट की प्रिसीजन बहुत ज़्यादा है, आपने जो इंस्ट्रूमेंट यूज़ किया है वो बहुत ज़्यादा प्रिसाइज है। ओके, दैट इज मोर प्रिसाइज बट दैट इंस्ट्रूमेंट इज नॉट accurate. So significant figures tells precision, not accuracy. That you should remember always. Significant figures tell the precision of the measurement. So significant figures communicate precision without changing the value's magnitude. Now there are some rules that if there is any measurement, how many significant figures are there in that measurement? There are some rules. First rule is all non-zero digits are significant. Examples: 42.7. In this measurement, how many non-zero digits? That is 3. So the 3 significant figures are there. Second, 1357, all are non-digit numbers. So 4 significant figures. 9.81, 3 significant figures. So no surprises here. Every visible non-digit counts. The interesting case, all involve zeros, which follows their own rules. So this is the rule for non-zero digits. All non-zero digits in any measurement are significant. This is first rule. Now, second rule, zeros sandwiched between non-zero digits are significant. जो जीरो दो नॉन जीरो डिजिट्स के बीच में होंगी वो क्या होंगी? सिग्निफिकेंट होंगी. एग्जाम्पल्स: 2.005. So two non-zero digits, 2, 5. So two zeros are between two non-zero digits. So that two zeros are also significant. So how many significant figures? 4. 1, 2, 3, 4. Okay. Now 1.06. This zero is sandwiched between 1 and 6. So this zero is also significant. Similarly for this 4007. So first rule was all non-zero digits are significant. Second rule, zeros that are between non-zero digits are significant. Third rule, leading zeros are not significant. Okay. So in the case of decimal, if number is less than 1, so that these leading zeros are not significant figures. Suppose 0.0025. So these are leading digits. If number is less than 1, if number is less than 1, so 0.0025. So these are leading digits that are not significant digits. So in this 0.0025, there are only two significant figures, 2 and 5, that are non-zero digits. In 0.0860, okay, there are only three significant figures. These two are not significant. This 8, 6 and this 0 is also significant. We will discuss it in next rule. And 0.4, this 0 is not significant. Only this 4 is significant figure. So only one significant figure is there. Next, trailing zeros in number with a decimal are significant. If number contains, if number contains a decimal point, then the trailing zeros means zeros after non-zero digits. These are the trailing zeros. These two zeros, this zero is trailing, and these two zeros are also trailing. That are after last non-zero digit. जो लास्ट नॉन जीरो डिजिट के बाद वाली जीरो है उनको क्या बोलते हैं? ट्रेलिंग जीरोस. So all trailing zeros after decimal point are significant. That is, there is a condition, trailing zero after decimal point. If there is decimal point, then so 4.700, these two zeros are significant, or these two non-zero digits are already significant. So four significant figures. And 1.020. So this 0 is sandwiched between two non-zero digits. So this is significant. Also this trailing 0 after decimal point is significant. In 0.0600. So this is a non-zero digit. This is significant. Okay. Now these are leading zeros. Leading zeros are not significant. These are trailing zeros after decimal. These are significant. So how many significant figures? 3. Okay, that's how you calculate. So this is fourth rule. Now fifth rule. Trailing zeros in whole number. If there is a whole number, there is no decimal point. Without decimal point, so trailing zeros are ambiguous. So the number 4700 might have 2, 3 or 4 significant figures. So it depends on that is 4700 is rounded off from 4732 or it is measured exactly as 4700. If it is measured exactly, अगर इसकी measurement किसी हमने क्वांटिटी की लिया है और एग्जैक्टली हमारे पास ये वैल्यू आई है 4700, देन इट हैज़ 4 सिग्निफिकेंट फिगर्स. पर अगर हमारे पास वैल्यू है 4732 और हमने राउंड ऑफ किया उसको 4700 पे, तब उसके पास 2 सिग्निफिकेंट फिगर्स होंगे. तो इस एम्बिग्यूटी को एलिमिनेट करने के लिए हम क्या करेंगे, साइंटिफिक नोटेशन. किसी भी क्वांटिटी कोई भी मेजरमेंट आती है तो उसको किस में लिखेंगे, साइंटिफिक नोटेशन में उसको रिजॉल्व करेंगे. तो बेस्ट प्रैक्टिस क्या है कि इन नंबर्स को जैसे ये वाले आते हैं, हमें एम्बिगुअस है कि इसमें कितनी होंगी, 4 होंगी या 2 होंगी, तो इसको साइंटिफिक नोटेशन में लिखें. लाइक दिस, राइट अ नंबर इन दिस फॉर्म, a into 10 is power b, where a is between 1 and 10 and b is an integer. A is called mantissa. So like we write 1.7 into 10 is power 5. Okay, so from here a is between 1 and 10 and this 5 is an integer. Any integer, positive or negative. Okay, and this a is called mantissa. Only its digit count for significant figure. Only a digit of this mantissa is counted for significant figures. Like this, 4700. If we are representing it in this form, 4.7 into 10 is power 3, then it has 2 significant figures, 1, 2. If we are representing it 4.70, that means its 1 0 is not significant. अगर हम इसको ऐसे साइंटिफिक नोटेशंस में ऐसे इसको लिख रहे हैं, इसका मतलब इसका ये वाला 0 जो है वो नॉट सिग्निफिकेंट. सिर्फ एक ही 0 सिग्निफिकेंट है, 4.70. And if we are writing it like that, 4.700 into 10 is power 3, that means it has 4 significant figures. So that depends on the scientific notation. Like 0.0025, it has 2 significant figures. If we are writing it in scientific notation, it will not change the significant figures. 2.5 into 10 is power minus 3. Again, significant figures are 2 and 5. Okay, so power of 10 is exact and does not affect the significant figure. So we do not count this thing for significant figures. Then there we have exact numbers. So the exact numbers, or we can say like we count the number of students, 1 2 3 4 5 6. So 6 students. So this is exact number 6. Exact number 7. The whole numbers. If we count something and we told that 12 things are there, so that is exact number, and exact number have infinite significant figures. We can write anything after putting decimal here and 0 0 0 0, infinite number of zeros we can write. So the exact numbers, like we have taken the measurement and it came out to be exact number, that is having infinite significant figures. Or the whole numbers, the counting 1 2 3 4 5 6, so that is having infinite significant figures. and they never limit the precision. You can write 12 in this form also. You can write 6 in this form also. So you can put any number of zeros. So they have infinite significant figures. Okay. Now there are some rules for arithmetic operation with significant figures. So if you add, you subtract two measurements, two quantities, you divide, you multiply, then what amount of significant figures, on what are the rules for arithmetic operations? How many significant figures, how many significant figures we should keep in the answer? And that is very important topic. Okay. So there are two rules. Rule is same for multiplication and division. Another rule is same for addition and subtraction. So for multiplication and division, the final result should retain as many significant figures as are there in the original number with least significant figures. So example, you will understand from example. So density is measured by mass upon volume. So there is division of mass and volume. If mass is given as 4.237 gram and volume is given as 2.51 centimeter cube. So how many significant figures are there in the mass? How many significant figures? 4. How many significant figures in volume? 3. So division of two quantities, mass upon volume. So according to rule, the final result, that means density, should retain as many significant figures as there in the original number with least significant figures. तो जिन दो क्वांटिटीज की डिवीजन या मल्टीप्लिकेशन हो रही है तो उनमें से जिसके पास सबसे कम सिग्निफिकेंट फिगर्स होंगी उतनी ही हमें रिजल्ट में रखनी है. दैट मीन्स द वैल्यू डेंसिटी 1.69 ग्राम पर सेंटीमीटर क्यूब. सो ये हमारे पास डेंसिटी आई, तो डेंसिटी में भी हमें 3 ही सिग्निफिकेंट फिगर्स रखनी है जितनी कि हमारे पास लीस्ट नंबर है. Okay, so 3 significant figures. Since volume 2.51 has the least significant figures, so we should keep that same amount of significant figures in the result. Similarly, speed of light is given as 3.00. How many significant figures? How many significant figures? 3.00. After that, we will do some questions. I will ask you the answer. I'm asking you, how many significant figures? 3.00. Okay, 3. Okay, it is written here. Into 10 is power 8 meter per second. So 1 year is 365.25 days, and it has 5 significant figures, 3, 1, 5, 5, 7. So 1 year is having 3.11 1557 into 10 is per 7 seconds. So that means that is having 5 significant figures, 3, 1, 5, 5, 7. So 1 light year is speed of light multiplied by the seconds in 1 year. That would come out to be 9.47 into 10 is power 15 meter. That is 1 light year. So we have least number of significant figures in speed of light. That is 3. So we should keep 3 significant figures in the light year also, because 1 light year is speed of light into 1 year. So in speed of light, there are 3 significant figures. So in result, that is in 1 light year, we should keep 3 significant figures. Now, next rule is for addition or subtraction. Rule is same for addition and subtraction. So the final result should retain as many decimal places as there are in the number with the least decimal places. Example, sum of number 436.32, 227.2 or 0.301 gram by arithmetic addition will give you this answer. So now tell me, in 0.301 gram, how many significant figures? 0.3. Okay, 3. In this 227.2, 4. And in this 5. Okay, yes, got it. I got it. So 3 significant figure, 4 significant figure, 5 significant figure. How many decimal places are there? So in this 2 decimal places, in this 1 decimal place, in this 3 decimal places. So rule for addition or subtraction is the final result should retain as many decimal places. Now rule is changed. In the case of multiplication and division, rule is according to significant figures. In case of addition and subtraction, rule is according to decimal places. So final result should retain as many decimal places as there in the number with the least decimal places. So which is the number with least decimal place? This 227.2, only one decimal place. So the result after adding these three numbers, we get this result 663.821 gram. So we should retain only one decimal place in the answer. So but the least precise measurement is this with least decimal places. 227.2 gram is correct to only one decimal place. So final result therefore should be rounded off to only one decimal place. That means 663.8 gram. This is the second rule for addition and subtraction. Similarly, the difference in length can be expressed as, suppose 0.307 minus 0.304. Both are having 3 decimal places. So in answer also, we should keep 3 decimal places, 003. Okay. Now we'll do some questions. A student measures three physical quantities as x equal to 0.003040 meter, y is equal to 2.030 into 10 raised to power 5 kg, and z equal to 400 seconds. The number of significant figures in x, y, and z are respectively. How many significant figures? D or A? Op- Option A. Okay. 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 S- Okay. So this 0 is non-significant, non-significant, non-significant. So these 4 are significant. So 4 significant figures in second. All are significant figures. And this, how many significant figures? 1. It is having one significant figure. It is not represented in the form of scientific notation. If it is represented in this form, then it is having three significant figures. But it is represented as 400. So trailing zeros, if number is not non-decimal, these trailing zeros are non-significant figures. So it is having only one significant figure. So B option, 441, is the correct option. Next, compute the value 4.32 gram plus 0.012 gram minus 1.2 gram expressed to the correct number of significant figures. So which arithmetic operation is there? Addition and subtraction. So you should have to use the rule for addition and subtraction also and write the final answer after adding it. Okay, I got it. Okay, option A, option C. Let's see. 4.32, 0, 1, 2, 1.2, 2, 3, 5. Oh, sorry, subtract. Okay, I got it. 2, 3, 3 minus 2, 1, 4 minus. Okay, but now, no, option A is incorrect. Okay, now I got your answers. Please mute your mic now. So there is two operations, addition, subtraction. The rule for addition, subtraction, we have to keep that amount of decimal places. Okay, तो जितने हमारे पास ये तीन टर्म्स दी हुई हैं हमारे पास, इनमें से जिसके पास लीस्ट नंबर ऑफ डेसिमल प्लेसेस होंगे उतने ही हमें रिजल्ट में रखने हैं. लीस्ट नंबर ऑफ डेसिमल प्लेसेस किस में है? इसमें only one decimal place. So we should keep one decimal place in answer also. So it is round off to 3.1 gram. So option C is the correct option. Those who have said C option, very good. Next question. The mass of uniform metal cube is measured to be 5.340 gram and its side length of the cube is 1.20 centimeter. The density of the cube up to appropriate significant figures. So density, mass upon volume. So 5.340 divided by 1.20 cube. So 5.340, 1.728. Okay, now you don't have to solve this. How many significant figures in the case of, so how many significant figure you should retain in 1.728? We have 1.20 into 1.20 in cube. So there is multiplication. So in multiplication, तो हमें रिजल्ट में कितने सिग्निफिकेंट फिगर्स रखने हैं? कितने हैं इसमें? 1.20 में कितने सिग्निफिकेंट फिगर्स हैं? How many significant figures are there in 1.20? 3 significant figures. So we should keep only 3 significant figures. So round off this 1.728. So it would be 1.73. after rounding off. So three significant figures. So we have to round off it. Now there is division between 5.340 divided by 1.73. In division also rule is same. So how many significant figures we should keep in result? That is the least 1.73. Three significant figures we have to keep in the result also. So which option is having three significant figures? Which option is having three significant figures? C option. In this there are yes, I got it. Option C is correct option. So 3.0902. So there are five significant figures. There are four, there are two. So we should keep three significant figures. So 3.09. That is the correct answer. Only three significant figures we should keep in the result. Any doubt? Okay, no doubt. Next question. Evaluate the expression 15.42 minus 12.1 upon 2.00 and express the answer to the correct number of significant figures. Now this is a mixed type question. In the numerator there is subtraction. Different rule will be applicable. After subtraction you have to do the division. Then there will be different rule for significant figures. Now tell me which option is correct. Firstly think and then tell me. So 3.32 is the answer. So after doing subtraction, you will get 3.32. But how much decimal places you should keep in the result? The rule for addition and subtraction. तो एडिशन एंड सब्ट्रैक्शन के रूल के अकॉर्डिंग रिजल्ट में उतने ही डेसिमल प्लेसेस रखने हैं जितने हमारे पास सबसे कम है, यानी कि 1 decimal place. We should keep 1 decimal place. So 3.3 here. So 3.3 divided by 2.00. Okay. So now there is division. So what is the rule for division? We have to keep that amount of significant figures जितने के लीस्ट नंबर हैं दोनों में. कितने हैं लीस्ट दोनों में सिग्निफिकेंट फिगर? किस में किस वैल्यू में है? 3.3. टू सिग्निफिकेंट फिगर्स. तो हमें फाइनल रिजल्ट में भी कितने सिग्निफिकेंट फिगर रखने हैं? 2. So which option is correct? ऑप्शन ए, 2 सिग्निफिकेंट फिगर्स. इसमें 3 है, इसमें 2 है, तो हमें रिजल्ट में लीस्ट वाले रखने हैं. 2 सिग्निफिकेंट फिगर्स. सो 1.7. Okay, so these are some questions, and now there's time for your next class. So thank you very much. If anyone is having any doubt, you can ask. Okay, bye bye. See you tomorrow. Okay.